Now that we have some experience understanding e to the x and log x, the inverse functions, we can solve some equations that involve e to the x and log x. Let's do some examples. So what if I wanted to solve e to the x squared plus 1 equals to 3? The key idea in solving any equation with e and log x is to isolate the e or the log x on one side of the equation and then apply e or log, the inverse function, to get rid of it. What I mean by that is in this equation, I already have e by itself on the left side of the equation. So you can continue solving by taking logarithms on both sides. So I'm going to take the natural log on both sides. If I do so, the natural log and e to the x are inverses. They undo each other. So the left side becomes x squared plus 1, and the right side becomes log e. So I took log on both sides. Now it's relatively routine to simplify. Log 3 is just a constant. It's a number. So I can solve just like I'd normally solve by subtracting 1 on both sides. So I get x squared is log 3 minus 1. And lastly, taking the square root, I get x is either plus or minus the square root of log 3 minus 1. Let's do more examples. How about the equation log x minus log x plus 1 is equal to 2? So the idea is, again, to put a logarithm or an exponential on one side of the equation and then undo it with the inverse function. I'd like to get one single log on the left side of this equation instead of 2, so I can use that property of log that says this is equal to log of x over x plus 1 equals 2. I did two things here. The first thing is I used this negative sign to raise x plus 1 to the minus 1 power. That's the same thing as division. Then once I did that, I combined these two terms using that property of logarithms that turns addition into multiplication, or vice versa. Now I'm ready to exponentiate both sides. So I'm going to take both sides to the e power. E and logs are inverses, so they cancel each other out. I'm left with x over x plus 1 is e squared, or e to the 2 power. E squared is just a number, so I can continue solving this equation in the normal methods. For example, I can multiply both sides by x plus 1 to get x is equal to x plus 1 times e to the second power. This is the same thing as e squared times x plus e squared. So I'm going to get all the x terms on one side of the equation. I'm going to subtract e squared. So I get x minus e squared x is e squared. I could factor out an x to get 1 minus e squared times x is e to the x. And then finishing up, I think we'll find x is e squared over 1 minus e squared. Let's try this type. What if I had e to the 2x power plus e to the x minus 2 is equal to 0? For this equation, I'm going to notice I have a quadratic equation in disguise. You can rewrite this using basic properties of exponents as e to the x power squared plus e to the x to the first power minus 2 equals 0. Then I could more easily see I indeed have a quadratic equation. It's a quadratic equation in e squared, in e to the x. So I can use a quadratic formula, and I can say that e to the x power, using the quadratic equation, is -1 plus or minus the square root of 1 squared minus 4 times 2, so plus 8 all over 2. And I believe if you do this, you'll get -2 and 1. So I have two options, and I'd like to take the log on both sides of this equation to get rid of the exponentiation. The problem is the -2. -2 can never be the output of e to the x. E to the x has range 0 to infinity. You cannot get out a negative number whenever you raise a real number to the x power. That means this -2 cannot be a solution. You could see that as well, because if you attempted to take logs on both sides, then you'd want to take log of -2. You can't take log of a negative number. That doesn't make sense. So the only solution here is e to the x power can equal 1. I take log on both sides, and I find x is log of 1. And we all know from the graph that log of 1 is equal to 0. So the only solution is x equals 0. If you're ever concerned if you have the right answer, of course it's a great technique to just plug in your solution into the original equation to see that it works. So if I plug in x equals 0 here, I get e to the 0, which is 1, plus e to the 0, which is 1, minus 2, and that does check out. Let's solve a couple more to end this video. How about if I had log x plus log x squared is equal to log of x plus x squared. Let's try this one. The first thing I'm going to do is combine these logarithms. When solving equations with log x is generally the right approach to try to consolidate the number of logs used. So I have the property of logs saying I can multiply x times x squared. This is actually log x to the third power equals log x plus x squared. Now I can exponentiate both sides. That's how I like to think about it. Or you can realize that log is a one-to-one function, meaning the only way two outputs could be the same is if the inputs were the same to begin with. Or you can raise both sides to the e and find that x cubed has to equal x plus x squared. So solving this, I'm going to get all the x's on one side of the equation. I'm going to factor out an x, so I get x squared minus x minus 1 is equal to 0. This gives me three solutions. I could see that x can equal 0, or I can use the quadratic equation here, and I think you'll find 1 plus or minus the square root of 5 over 2. So I have three different solutions to this equation, but I do not have three different solutions to the original equation because I can't plug in 0 into a logarithm. This does not count as a solution. You can't take log of 0 or a negative number. Similarly, if you have this negative root, it's not going to work. You're going to be trying to take the log of a negative number. So three of these solutions exist for the equation that is a polynomial equation, but only one of them actually works in the original equation. So the only solution is x is 1 plus root 5 over 2. I guess that was a good lesson. It's always a great idea to verify that the solutions that you get when solving equations in this way actually work. Let's finish the video with one final example. What if I wanted to solve log base 2 of x plus log base 3 of x is equal to 1? In this case, I'm going to transform a log with a different base back into the natural logarithm. I don't really like logs with different bases, so I always turn it back into natural log every single time, first step. So this is log x divided by log 2 plus log x divided by log 3 is equal to 1. I could factor out a log x. I will get 1 over log 2 plus 1 over log 3 times log x is equal to 1. trying to isolate the log x by itself on one side of the equation, just like we did in these previous problems, so I could apply the inverse function, which is e to the x. I'm going to divide by this constant. This is just a constant in front here. So I can write this as log x is equal to 1 over log 2 plus 1 over log 3. It's kind of a convoluted answer. Finally, I could finish by exponentiating both sides. I exponentiate, I think I will find x is equal to e to the power 1 over log 2 plus 1 over log 3. Okay, so here were a few examples of solving equations with e to the x and log x. I'd like to do a couple more examples of this form, especially in the context of applications, so see me in the next video for that.